So good afternoon, dear students. Can you hear me? Okay, then we can start. What did we learn in our last lessons? Who can repeat? This is a summary, short summary. Yes, Mahmoud. So what did we learn in our last lessons? Okay. It seems you are waiting till the exam, midterm exam. So in our last lesson, we were talking about the hydraulic actuators, and we discussed the topic hydraulic and how can we produce the hydraulic energy and how can we use that, and what are the actuators, linear actuator, rotary actuators. And in case of linear actuator, we said we have two types of linear actuator, like we learned in pneumatic. So let's share the screen and then continue with the screen. So hydraulic actuator, linear actuator, single acting and double acting linear actuator. Can you see the PowerPoint presentation? Okay, I think you see it because I cannot see your answer on the screen. I can check only listening to your voice. Okay. So, and then we said there are single acting and double acting type of linear actuator, as we learned in pneumatic. And we also discussed some hydraulic circuits, like you see here, hydraulic circuit, single acting cylinder. And to drive the hydraulic linear actuator, we use 3-2-way valve here, as you see here. 3-2-way valve, and return stroke occurs by the weight of the piston or piston rod together, piston rod or any load acting from the outside to the piston in the axial direction. So then single acting cylinder, we talked about the component. This is the piston and the piston rod here, and the annular piston surface and piston surface and the end cap and front cap and so on. And the, of course, here the sealing elements. So the double acting linear actuator, as you see here in the picture. so it can do the work in both direction. That means in advanced stroke and return stroke. Therefore, like in pneumatic, we said in both direction we use hydraulic energy to drive the piston and piston rod connected to the piston. So double acting cylinder with end positioning, we also discussed in pneumatic. This is the same here. We have two pistons here on the left and right side of the main piston. And you see here, these are this piston and this piston here. And there are locations here where these pistons are coming in and start the cushioning and so on, more or less the repeating from the last lesson. So then, okay, double acting. I mean the cushioning type of this cushioning function we learned already in pneumatic, and also we mentioned in the hydraulic in our last lesson. So there is also a double rod cylinder, like here you see it's double rod cylinder. We learned also in the pneumatic. That means double rod, this linear actuator has double rod. And the important is that the cross-section area of the piston are the same from the left and right side, because they have left and right the piston rod connected to the piston. So that means if we use this type of cylinder, we have the same force in the right and left direction in advanced and return stroke. So then we said, okay, double acting cylinder, how can we derive the double acting cylinder or double acting linear actuator? And we said we use 4-2-way valve. We learned 4-2-way valve, isn't it? Huh?
Yes.
Okay. So we use 4-2-way valve to drive the double acting cylinder, and in this position, the piston makes return stroke, and in this position, piston makes advanced stroke. So, and this is the power unit we learned, and in power unit we have the electric motor and pump, and here we have the pressure relief valve to adjust the pressure for a certain level. That means for a level which is for all the system is safe. So you know the pressure is important in hydraulic system, but is also dangerous. So we have to keep the pressure in a certain level, which can be safely carried by the system. So therefore, we have here pressure relief valve, and you see this narrow here. We adjust the pressure for the system pressure, system level, and then we don't touch it. It comes from the producer of the power unit. Producer of the power unit make this adjustment, and nobody should touch it and change it, because it is the important issue related to the safety of the system. Okay. So then we discussed the type of cylinders here, differential cylinder, where we have interesting properties regarding the piston. So that means the piston on the piston rod side of the piston area of the piston rod side is the half of the piston area of the back side. So this is the proportion of the area. This is 2 to 1, and this we call differential cylinder. And differential cylinder means so the area relation between the piston rod side and the back side are 2 to 1, and it affects the forces. I mean, if piston make return stroke, then piston can apply the half of the advanced stroke force. So then We have a double rolled cylinder like here. We have double rolled, we discussed already, and we have here cylinder with end position cushioning. And this is, you see here, between on the left and right side of the right and left side on the main piston, there are two small pistons which we use for the cushioning, and there is an arrow on that. That means it is adjustable. So then we have here we have a telescopic cylinder, telescopic linear actuator. This is the symbol of telescopic linear actuator. So in order to create more stroke in a short, let's say the short volume of the linear actuators, we use telescopic cylinders. And here we have the pressure intensifier, or the pressure increaser. So we increase the pressure using those type of equipment, and this is the symbol of that. We have here the big area, here we have small area. If we apply, let's say, the 10 bar to this big area 10 times, let's say this is the 10 surface, 10 times 10, 100. So then on the other side, if we have 5, so this cross section 5, that means we increase the pressure 2 times. So because of the surface relation. So then another type of cylinders, so linear actuator is tandem type of cylinder. Tandem means if we want to more force, if we want to increase the force by linear actuator, so then we use integrated in the same body, in the same housing, integrated pistons and the piston rods. Like here we have one piston and this is the second piston are integrated together via the piston rod here. So that means we increase the surface of the pressure acting on it here. This is the first surface and the second surface, and it could be one more or three or 4. So that means we increase the surface, and if we have more surface, and that the force, the force is equal surface time pressure. So if we increase the surface amount of the surface, that means we increase also the force for the same pressure. Okay, we are coming to the hydraulic motors. So we will talk hydraulic motors. That means rotary actuators. But before we start with rotary actuators, so I want to use the the simulation software, and I'll show once more how we derive the hydraulic linear actuators. So as you know, we use this is the power unit here, but instead of that we can use also this one. So this means also power unit. This is the more let's say detailed symbol. This is the say the abbreviation of that, and so simplified, and this is really the real one. So I prefer to use this one because we see all the components also here, like electric motor, pump, anti-pressure relief valve, and so on. And it's our power unit. As I said, so to drive the cylinder, we learned already that we have 4 two-way valve like this. For the double acting cylinder, for the single acting cylinder, we use 3 two-way valve. So this is the valve we can use to drive the linear actuator, double acting linear actuator. This is the pump side. We have to connect to the pump, and this is the tank. Has to be connected to the tank like this, and you can easily follow that in pneumatic, we put it into the atmosphere, but in hydraulic we cannot. And also the air is, let's say, free of charge from the atmosphere, but oil is not free of charge. So that means we have a closed cycle, so that the oil or fluidic is running in this cycle, and this is the returned oil, and this is the oil, the pump from the pump into the system. So if we start the simulation, you'll see now it's all the power unit is already working, and we have here hydraulic power, as you see here. So, and they connected by the two-way valve to the linear actuator in the front part of the front side of the linear actuator, and then push the piston back its initial position. So if I operate the valve manually, as you see here, the valve will take this position. So this position will be released, and this position will be active. And then if this position is active, you see the piston moves forward, because the pressurized oil is connected to the output A, and the output A is connected to the backside of the piston or linear actuator, so that the piston moves forward. And the oil in the front part of the piston or cylinder has to be flow into by the valve into the tank. Okay, so if I release the operation force by hand, so then by spring, you know, this valve will take by spring its initial position like this, and in initial position, P is connected to the output B, and B is connected to the port B is connected to the front tile of this cylinder linear actuator, and then piston moves back its initial position. So then we said this is for two-way valve used mainly in hydraulic, and we learned also in pneumatic that we don't use this valve in pneumatic. Instead of that, we use 5 two-way valve in pneumatic because of the speed of pneumatic. We have to, and this speed is mainly also related to the exhausting of the air inside of the piston, and therefore we have 2 exhausts for each position of the valve, so that we can very quick exhaust the air from the piston, so that the piston moves more quickly. Okay. So, and then we said, if you want to keep the linear actuator or the piston in a position between end position, you know, these are the end position here. This is the end position, and the initial position, and the front position. Those are the end position, and piston is moving, like you see, between the end position, front or end. So we cannot keep the piston in between, I mean, in between these 2 positions. So the limited position, front and end. So, and instead of that, so if you want to keep the piston so in between somewhere, that means we cannot realize that we realize by this valve, because this valve has this 4-way valve has 2 position, and the 2 position means one of them is responsible for to drive it forward, and the other one is responsible to drive the cylinder back its initial position. So therefore we need 1 more position. So 1 more position, that means 3 position, and then we can use here the valve with 3 position like this. Oh, I have to stop the simulation. Okay, let's take it to the side, and you see instead of that we'll use the valve with this position. Okay, so like this valve, for example, here. So, what is the difference between these two valves? This valve has the middle position. So middle position, and this valve has not middle position. It has only two positions. One is for advanced stroke, the other one is for return stroke. Okay, then the middle position, you see in the middle, all the ports are closed. I mean, the P, T, A, B are closed. And therefore, there is no motion regarding the fluidic in any direction from the cylinder into the tank or from the power unit into the cylinders. Not possible, like you see here now. I established the connection here. So, okay. So, like this. So, and I have to take out here. This is, of course, for three-way valve. Sorry, four three-way valve. That means 4 connections and 3 position. So if we start the simulation, you see in this position valve, the cylinder doesn't move. So, and in that position, piston moves forward, and there is no spring. So I have to operate the valve manually. So if I operate from that side, so there's no motion, and here in that side, and in this position, like we learned before, piston moves back its initial position. So then if I here, let's say, start to move forward, and if I stop or change the position of the valve or operate the valve, bring the valve into the middle position, you see piston is somewhere in between between two end position. And if I operate once more, the piston will complete its motion in advanced stroke like this. So, and as a summary, we can say, if we need to stop this cylinder or piston between the end position, then that means we need additional position regarding the valve driver. So valve we can call also driver, and drive unit driver. Driver means, I mean, we operate, we control the cylinder. Okay, so in middle position, so we can keep the piston inside of the cylinder somewhere in the middle position like this. So like this. Like this, we keep here, and then I can bring back, or I can bring forwards like this. Okay. So okay. So we can drive the piston as we want, like we want. So another important thing is we didn't discuss in our last lessons. So to control them, to control two important parameters, to adjust and control two important parameters regarding the piston or linear actuator. So what are the parameters we use to calculate the power of hydraulic? How can we calculate the power of hydraulic? We learned already. So, okay, you forget it, huh? So we said in order to calculate the power of the hydraulic, we use power hydraulic is equal, we said, pressure times flow rate. So flow rate. And the unit of pressure is Newton per meter square. And the flow rate, unit of the flow rate is cubic meter per second. So then the power hydraulic is equal, the unit is Newton meter per second. So comes from this multiplication. Or instead of Newton meter per second, we can write watt. Watt is also the same. So there are two important parameters, as you see here. Two important parameters. One of them is the pressure. The other one is the flow rate. So the pressure is related. Pressure is related. Forces and torques, and flow rate is related speed. So two important parameters in hydraulic and also in pneumatic. And so our aim is how can we adjust the pressure and how can we adjust the flow rate. So by adjusting the pressure, we can adjust at the same time forces and torques. And by adjusting the flow rate, we can adjust at the same time the speed of the actuators, for example. So therefore, the pressure control or flow rate controls are very important. How can we control the pressure and how can we control the flow rate? So there are some valves we use to control the pressure and to control the flow rate. And we will discuss these valves now. Because in order to use the linear actuator in a right way or the correct, sometimes we need to adjust the speed or the forces and so on, and therefore we need those equipment and pressure regulation and the flow rate regulation. Okay. So then, if we come back to the fluid simulation, so to regulate or to adjust or to control the speed, we use, as we learned already in pneumatic, the one-way flow control valve. And this is this valve here, used in hydraulic. And it is also possible to use in pneumatic technology, has also the same valve. Okay, I need more place here. Okay, so, and I can easily adjust the, let's say, the speed in advanced stroke. Let's see that. So, okay, start simulation. So I will take, oh, sorry, I will take out this 4 3-way valve instead of the 4 2-way valve. I will use 4 2-way valve. What is it? Yeah, okay, 4 2-way valve. I will use, okay. So then let's start the simulation. You see, moves forward. So, and I can reduce the speed like this. And you see, so it doesn't move, huh? Or very slow, because we have to open a little bit. This is too much. What's that? Okay. You see, it moves quite slow. Okay. And if we need, mainly we use the flow control for the advanced stroke, because the in most application, the piston execute the work in advanced stroke, and therefore, by the execution of the work, the speed has to be adjustable. So we have to, considering the process, we have to be able, we need to adjust the speed. And therefore, I put this speed control valve in this part, I mean in the advanced stroke. But it's also possible to use this in the return stroke. So if we copy that and push here, use here. So then also in both direction, we can control the speed in both direction. I mean in advanced stroke and in return stroke. Huh? So it is same, huh? Return stroke. Okay. Advanced stroke and the return stroke. So, and this is an important opportunity, or the possibility that we can quite easy adjust the speed, and considering the process, or what is the needed speed, or what is the suitable speed for the process. This is, if you know that, we can easily adjust the speed, the linear actuator speeds, very comfortable, like this. Huh? So, okay, this is one way flow control valve. That means only in one direction we can control the flow rate. You see here, in that direction, this is open here. That means the return oil come from here to that into the tank. But here, the return oil also from here. This is the one-way valve. Not returns oil doesn't use the section which is restricted. So use this line which is open to the tank, and with, let's say, the less resistance, oil or fluid can flow into the tank. But if we apply here the pressure, you see the pressurized hydraulic oil has to pass this this line, and in this line we apply the section reduction, and that's the reason we reduce the flow rate, and by reducing the flow rate, we reduce the speed of the actuator actually. Okay, this is the speed control we have. So that is not, and component description we have. It seems like this. For example, you can turn this bottom left and right, and then by turning left and right, you can easily adjust the speed. So there is also, as far as I know, some video, I guess. Where is it? Yeah, okay. So here we have hydraulic, where is it? Okay, electrical, hydraulic. Let's use that. So then, flow and pressure. So flow, physical principle, flow and pressure. So let's see that first. Flow and pressure. Can you see the video?
In a narrow passage called a throttle, flow velocity is higher. This causes turbulence.
We can see the video.
Pressure.
Okay.
The higher the flow velocity, the lower the pressure. Our experiment shows this clearly. The lowest water column is over the narrow passage in the middle tube, which means that pressure is lowest at this point.
So, okay, it was the relation between pressure and flow rate. And then, but I want to pressure fundamentals. So, pressure fundamentals. Let's see what is pressure. Hydraulic filter, no. Power pack. Applications. The speed advance. Okay. Speed. Applications. Let's see that. How can we control the speed?
But in this machining complex, we want to achieve the following rhythm of motion. Tool advances rapidly, machine slowly and with maximum force, retracts rapidly. For this circuit with the three motion phases, fast retract, fast advance, and slow advance, we need a 4-3-way valve. We can achieve slow advance and fast retract with the valves that we've learned about up to now. What must the switching position look like to achieve the additional fast advance motion?
Okay. So then the flow rate, flow control. So for the speed control, we need to control the flow.
Here, the advance for machining must be load independent, since uneven advance would cause uneven machining. A two-way flow control valve provides a uniform advance speed.
Okay, and the so the flow control principle and flow characteristic, and let's see this video.
Different points within a hydraulic system have different cross-sections. But because flow rate is the same throughout the system, flow velocity is higher through narrow passages. At flow velocities of less than 4 to 6 meters per second, the fluid flows evenly, although slightly faster in the center of the pipe than along the walls. This is called laminar flow.
Okay. So can you hear the voice also? Yes or no?
Yes, we can hear the voice.
Okay, nice. So let's continue with the videos regarding the flow control.
Valves like this consist of an adjustable restrictor and a regulating restrictor. The desired flow rate is set on the adjustable restrictor, which at the same time sets the desired piston speed. As the load on the cylinder increases, pressure in the working line and at the valve outlet rises. Along with a spring, this pressure acts on the regulating restrictor, which in turn opens and balances out the increased resistance. This way, the increased outlet pressure doesn't extend all the way to the pressure relief valve, which would result in an undesirable change in the flow rate.
So in this video, you are seeing that the external load, if we change the external load, that means if we have dynamic external load, so the speed adjusted shouldn't be changed, I mean, by itself. And therefore, we need a special valve for that. So the special valve, speed regulator, the independent behavior of the external loads, I mean dynamic or static, doesn't mean anything. So the adjusted speed doesn't change. So there are in hydraulic different applications based on these applications. Sometimes we use this type speed regulator, which is not sensitive against the dynamic load, external dynamic loads. And if we need that, so it is also possible. And we learned already in pneumatic, this is not possible because we cannot adjust the speed for a constant value. Speed is changing since the energy is transferred by the air. But here in hydraulic, we transfer the energy by the fluidic, and fluidic is not compressible. Air is compressible. Okay, let's have another flow control principle, another video.
There are two ways to restrict flow. Here we see restriction of oil supply. Restricting the flow in the supply line for advancing the piston causes the oil to heat up. But warm oil reduces the precision of piston motion in the cylinder. In some machines, this isn't important. But this machining complex requires greatest precision, so that any rise in oil temperature is undesirable. So in a case like this, it's better to restrict the flow in the exhaust line. By this, we mean that the flow of oil to the tank is restricted, because it doesn't matter if the oil heats up. At the same time, the cylinder piston is hydraulically clamped, which improves precision. But remember that the surface area ratio between the pistons must cause a transmission of pressure to take place. So the system must be suitable for the resulting high pressure.
Yes. Yes, it's important. Okay. Another video for the pressure regulation.
Here we can observe another phenomenon that occurs when a restrictor is used. The greater the load, the slower the feed. Just why is that?
So you see, once more, they start at the same time. I mean, they start at the same time. And the restrictor, the restrictor flow control valve is adjusted same for both of them. But on the right side, we have load, and on the left side, we don't have load. And you see the external loads affect the speed for the restrictor. If you use the
Here we
restrictor.
can observe another phenomenon that occurs when a restrictor is used.
Yes.
The greater the load, the slower the feed. Just why is that?
So that means the restrictor we use like this. Sorry for that. So restrictor we use. This is the like a moment. Where is it? Oh, here I can use this one. So the restrictor. Oh, this is not possible. So then I have to use it in that way. So restrictor means it is like this one. Huh? So we reduce the cross section of the line. This is the line. We reduce the cross section and we can adjust it like this, shown by this arrow. And this is the valve, which means we can reduce the cross section of the line. And by reducing of the cross section, we reduce the flow rate. And if we reduce the flow rate, we reduce the speed. That means, so this is for the restrictor. I mean, this type of valve is dependent on the external load. If the external load is changing, then the adjusted speed is also changing. But instead of that, if we have such a valve, which we learned, speed regulator, let's have another color like this. It seems this is nearly same, but this is not the same. You see here. So there is also an arrow here to show the adjustability of the flow rate, but there is an arrow here. So like this. So this is this type of this. If you see this symbol on the valve, that means this is not sensitive against the changing of the external loads. And therefore, in hydraulic we need we have two of them. I mean, as speed controller, and this is dependent on the external load. This is not dependent on the external loads. Okay. So let's come again here, and we finish. We have one more, and then we stop then.
A load-dependent control system can be set up with a flow control valve.
You see, it's not dependent. They arrive the final stage at the same time. This is the flow regulator, speed regulator, and the other one's the restrictor. Okay, let's make a break, 15 minutes. After 15 minutes, we meet again, okay? That means 20 past 2, we meet again. Any question?
Thank you, Joe. We will wait after the break.
You are welcome, okay? Okay, we can start now. Can you see the PowerPoint presentation?
Yes, we can see it.
Okay, thank you. Thank you. Let's continue then. Okay. Okay, we discussed the flow rate regulation. That means how can we reduce or increase the flow rate and affect the speed of the system, mainly of the actuators, speed of the actuators. So then another important parameter is the pressure. So how can we change the pressure? So how can we increase or decrease the pressure? And what are the valves which allowed us? So we will discuss now this part. First of all, let's see some video about the pressure. So flow valve. Flow valve principle. Flow rate into. So I have two more videos. I want to share with you with the flow rate, regarding the flow rate.
If it takes about 10 seconds to fill this 2-litre container, then the flow rate is 12 litres per minute, or 0.2 of a litre per second.
Okay, flow rate, how can you measure the flow rate? Volume over time, huh? So this is the video. And the other one, the principle of the flow rate flow control valve. So this is an important video is shown now.
Here we see first the working speed of the cylinder when the restrictor is open. If the restrictor narrows the passage through the line, pressure rises upstream of the point of restriction.
This is the
This
restrictor.
causes the pressure relief valve to begin to open, and the flow rate is divided. One part of it flows to the cylinder, the other back to the tank. So flow rate is reduced by the interaction of two valves. Using the restrictor increases pressure by.
So you see, this is the restrictor. That means we reduce the cross section, the oil passing through. So if we reduce the cross section, that means the flow rate, total flow rate, cannot pass through this section. So actually we divide into parts of the flow rate. One is passing through this restricted section into the cylinder. The other one is passing through the pressure relief valve into the reservoir. So these two valves are working together. If we reduce the section, cross section, and create resistance for the flow, so then because of the resistance here, the pressure increased here in that part of the line. The pressure increased. So, and the pressure arrives the level of the pressure relief valve. So we adjust it. Then it starts to open slowly, and partly the flow rate flow via the pressure relief valve into the reservoir, and partly its flow depending on the cross section. I mean, we reduced the partly flow into the cylinder. So we divide the flow rate, the total flow rate coming from the pump. You know, the pump is delivering the oil, and the pump has a theoretical flow rate capacity, and the flow rate defined via the pump. So the total flow rate coming from the pump, we divide using these two valves, pressure relief valve and the restrictor, and by this mechanism we are able to reduce the amount of the flow rate and affect the speed of the piston in advance or return stroke.
Opening the pressure relief valve and channeling part of the flow rate back to the tank.
So once more, this is very important. We have to know that.
Here we see first the working speed of the cylinder when the restrictor is open. If the restrictor narrows the passage through the line, pressure rises upstream of the point of restriction. This causes the pressure relief valve to begin to open and the flow rate is divided. One part of it flows to the cylinder, the other back to the tank. So flow rate is reduced by the interaction of two valves. Using the restrictor increases pressure by opening the pressure relief valve and channeling part of the flow rate back to the tank.
Okay. So this was related to the flow rate. How can we reduce the flow rate and affect the speed of the linear actuator? So let's talk about the pressure relief valve. What is the pressure relief valve? Now we are going to discuss the pressure control. Pressure control. How can we change the pressure?
When a load has to be pulled, the piston can drop uncontrolled during the switching process. A pressure relief valve can prevent this. The valve is put into the line for the outflowing oil and set for the load. This means that it serves as a counter-pressure valve. Not until pressure is applied to the cylinder does it advance. For the piston to retract, the pressure relief valve must be bypassed with a check valve.
Okay. So that means now we are, let's take it away. So we are discussing the pressure control. So pressure control, you know the pressure relief valve. You have seen the symbol of the pressure relief valve like this. So the pressure relief valve. So this the tank here has to connect it to the tank. This is the pressure side. So, and here we have the spring. We can, using arrow, we can adjust it for the level, let's say the 50 bar. So 50 bar. And this is the arrow show in that direction. That means, and here we have a control line from the entrance of the valve to the in part of the valve. So this is the pump side. That means, let's say we have here the pressurized air come from let's say here. So pressurized oil come from here, and here the connections. And let's have here a pressure gauge. That's the manometer, and we check the pressure. And pressure must be actually maximum here 50 bar. Show 50 bar because we adjust for 50 bar. So what's happened now? If the pressure increase in this line and arrive 50 bar, this valve opens and allow the fluidic flow into the tank. So how can it happen? So the valve, at the beginning, at the entrance of the valve, there is a control line. You see, and this control line is connected to the inside of the valve, and inside of the valve, it's checked against the spring force. So if the spring force, we adjust the pressure by using here the spring force, and if there is two forces compared by this valve. One of them is the spring force, the other one is the pressure force. And I can show here how does it really work. So this is as you have seen already in the pressure relief valve, this is this part here. And this is the gap here. Let's use another color here. This one. Here is the this part. So this is the gap. Oil come from here. So it's not easy to write. Okay. So no. Okay. So the working principle of this pressure relief valve. So this is the line here. I have shown here the line. That means oil is connected to here. Let's show the blue one. So the blue. So oil pressure here is the oil. Pressure of the oil here is the oil, and so here the oil, and this is the cross section here affecting. Let's use again the black one. This is the cross section here. So affected projection area like this. This is the surface projection area, and force on this area, F oil pressure, let's say, is equal. Let's say this is the area A times area times pressure. Area times pressure. This is the oil pressure here. P. Let's use the color P. This is the P here, the pressure. So, and on the other side we have a spring. Here the spring like this. So, and let's show the screw here. So by turning, let's say the left and right, or down and up, so we can change the displacement regarding the spring here. Huh? So this is our spring. So spring. So that means, let's say that at the beginning the length is L0, and then if we using the screw mechanism, it will reduce the length of the spring, let's say to L1, and then we have changed the total length of the spring is equal, delta L is equal from L0 minus L1, so delta L. And you may remember the spring force is spring force is equal delta L displacement times the spring constant. Let's say the K, spring constant. So that means on that side here, we create a spring force, and this spring force must be in balance or in equilibrium with the pressure force coming from the oil and acting on this surface. So say we can see how does it. I mean the equation wise, how does it work? How can we adjust the pressure on the oil side using the spring? So you will see now, here we have, oh no, it's wrong. So the column, okay. On that side we have area, pressure times area. On the other side, let's say it's equal to each other. On the other side, delta L times spring constant. And you can easily follow that here in these equations, spring constant is constant, and the area is also constant because we cannot change the area here, the cross-section area here. So I show you that the cross-section area here, I mean this one here, we cannot change because it depends on the geometry. I mean, it is already selected and designed, so we cannot change it. And in these equations, you see in these equations there are two parameters. On this side pressure, on the left side pressure, on the right side is length of the spring. So that means by changing of the length of the spring, we can change the pressure. This is very clever invention, I must say. So as engineer, you should know that. So there are so simple solution in technique, but somebody has to think about and has to create these type of solution. Sometimes we need really very creative to find a simple solution, not complicated solution. So this is one of them. It's very fascinating. You see, by a screw mechanism, by changing the length of the spring, you can change the pressure on the other side. Okay, so the pressure relief valve, this is the function of the pressure relief valve. How does it work? And so maybe I need to show you some videos. There are also other types. This is pressure relief valve, and we have also pressure adjusting valve and pressure regulator and so on. Different name, but this is pressure relief valve, and this pressure relief valve affects all the pressure in the systems, hydraulic systems. Now I will establish a circuit, and I will show you what I mean. So here, so we have such a circuit. So I'm going to use an additional pressure relief valve. So this is one we have here, but this pressure relief valve which we have in power unit, we will not touch it. We will not touch it. It is not allowed because it is adjusted by the producer of the power unit, and it is the maximum limit of pressure you can use using this power unit. So it is very dangerous. If you change the pressure of this valve inside of the or on the power unit, you take the responsibility, and the producer lose its responsibility because it is a must. Nobody can change it, nobody can touch it without the producer. So, but we shouldn't, sometimes we need to drive our system not with, let's say, the high pressure like adjusted on the power unit. So maybe we need, let's say, our the pressure relief valve is adjusted to 100 bar, but we need maybe 60 bar in our system. So what shall we do? So we can use another pressure relief valve and reduce our working pressure. We can reduce our working pressure like this here. Okay, here. So, and this we have to connect to the tank here. Let's connect here somewhere. Okay, connected to the tank. Okay. So, and let's have an manometer and the pressure indicator here. And now let's drive the systems and see the pressure relation. So here we have 3.5. Let's see what is that. So this is 40 bar and 6 bar. Let's say we use 30 bar, 30 megapascal. Okay. This is 30. And this is here, you see, if we increase that over the 30, you will see the flowing is here will be stopped. So it is stopped, cannot work anymore because I increase so much the pressure here on this pressure relief valve, so that these pressure relief valves start to open and bypass the oil into the reservoir because it is adjusted to the 30. If the oil pressure arrives at 30, that means this is say the fuse. This is a safety valve in that meaning, in this meaning. So it opens the pressurized oil into the tank and stop to increase the pressure. So, but if I decrease the pressure here, you see the function of this valve here. Let's see that this is closed now. This is not open. This is open. So, and since it is open, you see P is connected to the T. P is connected to the T. Yes, you observe once more. So P is not connected to the P, but here P is connected to the P. That means this valve is opened and pressurized oil is flowing into the tank. So that means I can work here with a different value of the pressure. That means which is let's say 20 or 15. That's 15. Let's have a 15 here, 15 bar. Okay. So here I have 15 bar, but here the adjusted is 30. But I don't use the 30. I don't need the 30. 50 is okay. So I don't produce the energy, hydraulic energy with 30 bar. It costs money, So it needs energy to produce a hydraulic energy with 30 bar, and don't use it. It is not not efficient, not correct way. So therefore, I use another one, the pressure relief valve, and I adjust that to the pressure value which is sufficient for me, like 15 bar, and I work with them. Okay, you see, if I start the motion, you will see it will stop. But it is not stop. Why not? Because I use the restrictor here. And because of the restrictor, there is a resistance. So the pressure increase. If I open, let's say the full, and here I will open full, and then you will see during the motion, it will stop here to the oil will stop to flow via the pressure relief valve into the tank. You see now. So, and after arriving final station, so then oil has to flow because pump is delivering the oil. So oil has to flow into the tank like this, or vice versa. So during the motion of the cylinder, there is no the pressure relief valve is not in action. But after arriving the final position, I mean, after arriving in the final position, the oil cannot flow anymore, and then pressure increase. Then the relief valve opens and bypass the oil into the tank. Okay, this is the pressure situation. It's very important. So, how can we reduce or increase the pressure? But if we need, let's say, to adjust the pressure here, let's say on the piston side, so then they have to use another pressure regulator. So let's find it, because if we can regulate the pressure on this side of the piston, that means we regulate the force acting on the piston. And then let's have the pressure relief valve. Where is the pressure? Sorry, pressure regulator, pressure control valve. Okay, this one, for example. Pressure regulator, I can use this one. This has to be connected to the tank. Okay, and this has to be connected to here. Okay, then this we have to connect here. And now we will use another pressure indicator like this here. Okay, to see the pressure here. And of course, we need another line to open the oil during the return stroke of the piston, the oil has to flow into the tank. So free flowing we need, not via the pressure regulator. So therefore we need a one-way valve. One-way valve. Where is it? Here somewhere. Okay. For example, this one. And let's rotate it. Okay, this is correct. Here I have to connect it. Okay, then also here. So then you see, if oil flow into this into the backside of the cylinder from here, so cannot flow by this one-way valve or check valve. It is not allowed to flow from B to A, but it is allowed to flow from A to B. This is the reason why we say one-way valve. So like this. But if I said if the valve take this position, the P is connected to the B and to the A, sorry, and then oil has to flow via the pressure regulator, so that I can regulate the pressure. I can keep the pressure level which I have adjusted. So let's see how does it work. So you see, I already adjusted here 15 bars, and what is the pressure here? 3 bar. You see, this is 3 bar. So adjusted for 3 bars. Let's say 10. Let's have a 10 bar, and we will see that 10. Okay, here we have 15. We have here 30. And we always here see 15 because this is not more than 15, because in 15 bar this valve opens and bypass the oil into the reservoir. So then let's start. So in that direction, you see this is maximum 10 bar. You see here the back side of the cylinder, we have 10 bar pressure. Here we have 15, always everywhere 15, but here this is back side of the cylinder, we have 10 bar because of this pressure relief valve. So not more than 10 bar. So this we need, because 10 bar means this cross section of the piston times 10 bar is the force acting via this piston rod. So therefore, we are able to adjust the force acting via the piston rod, and this is very comfortable in hydraulics. So you can adjust the force on the piston rod very comfortable. Okay, this is pressure regulator. 3-way pressure regulator. Why 3? Because it has 3 connections. PAT. T to the tank, P for the pressure, A is for the output to the cylinder, for example. Okay, let's check whether we have the some videos about so pressure relief valve we already have seen, but maybe once more. Pressure relief valve.
In this circuit, the motor is not to start running until a certain pressure.
So this is another thing. So this is not what we want.
Its job is to prevent a preset oil pressure from being exceeded.
This is pressure relief valve.
As pressure approaches the preset value, the valve begins to open, and some of the oil flows back to the tank. This pressure is also called opening pressure. When the preset pressure, that is, the maximum system pressure, is reached, all of the oil flows back to the tank. This prevents pressure from rising any further. If pressure drops, for example because a directional control valve has reversed its direction, the pressure relief valve closes again.
Okay. And what is this? Let's see.
The pressure at the valve outlet acts on a control piston. When pressure rises, the control piston is moved against the force of the spring. Under certain conditions, this could happen while the piston is still moving in the cylinder, if a corresponding load pressure must be produced. If pressure continues to rise, for example because the cylinder has reached its end position, the control piston continues to shift until it completely blocks the pressure line, which prevents the preset value from being exceeded.
So, this is the pressure regulator. So this is the cylinder side. This is the linear actuator side. And at the beginning, you have seen this is completely open here. So, or let's say here, it's completely open. That means the oil coming from the pump flowing into the cylinder. But they have adjusted a certain pressure for the outcome. So the outcome, for the output. So this is adjusted, or this is adjusted by the spring force here. So you see the pressure on the output is also connected to this side of the piston here. Can you follow it? There's a here channel, and by this channel the pressure, the oil is connected to this side of the piston, and that means we have here a certain pressure force coming on this surface come from the oil, and here also. So that means we are this by this piston we are controlling the pressure on the output side of the valve. So we adjust a certain pressure by spring force, and if it is arrived on the outside of the on the output of the output part of the valve, so it affects from here and push the piston in that direction, and so that the piston close this gap here. So this is the incoming oil. This is closed. So like this, you see, then oil cannot come anymore into the valve. So that means the pressure cannot increase. It stops increasing of the pressure. So let's check once more. Listen
carefully. The pressure at the valve outlet acts on a control piston. When pressure rises, the control piston is moved against the force of the spring. Under certain conditions, this could happen while the piston is still moving in the cylinder, if a corresponding load pressure must be produced. If pressure continues to rise, for example because the cylinder has reached its end position, the control piston continues to shift until it completely blocks the line, which prevents the preset value from being exceeded downstream of the pressure regulator.
Okay. So you see, the pressure regulation is also very comfortable. We can easily adjust the pressure which we need for our circuit, and by adjusting the pressure at the same time we are able to adjust the forces in this hydraulic system. What is that actuation valve?
You'll now see several ways of actuating hydraulic valves. Manual actuation by lever, or by foot pedal.
Actuating of the valve.
Now, here are examples of mechanical actuation. Actuation by roller lever or by spring. These valves are actuated electrically.
So, you have seen the way of actuating of the valves. So, manually, by spring, by foot, and by electric, and so on. So, we have a video about the fundamental circuits. That's also interesting for you.
This hydraulic pump is an external gear pump. This is how fluid flow is created. The suction chamber is connected to the oil tank. When the two gear wheels turn, the volume of the chamber increases slightly whenever a tooth leaves a gap. This creates a partial vacuum in the suction chamber, which then causes the oil to be drawn out of the tank. Oil is transported between the gear teeth along the chamber walls to the pressure chamber. The intermeshing teeth prevent the oil in the middle from flowing back. The oil now flows from the pressure chamber into the line, where it's displaced by the oil being supplied continuously from the gear wheels. Initially, the pump doesn't create pressure, but only a fluid flow. Not until the fluid meets with resistance, for example line resistance or a load, as in the case of our platform lift, does hydraulic pressure build up. When pressure is higher than the resistance of the workload, the piston begins to advance until it reaches its upper end position. If the pump continues to supply fluid and pressure continues to rise, something will eventually have to give. Either the line will burst, or the pump or cylinder will be damaged. This is prevented by a pressure relief valve, which is set to the maximum pressure of the pump. It doesn't open until this pressure has been reached, at which time it channels the hydraulic oil back to the tank. It's usually combined with a pressure gauge to form a unit. The external gear pump generates a constant flow rate because delivery rate is kept at a fixed quantity by the gaps between the gear wheel teeth.
Okay. So, again, let's have a break and we meet 15:20. Do you have any question? Okay. Okay, I can. I guess. I think we can start, huh? So this is our third lesson, and in our last lesson, I mean the first one. So we will discuss the homework, and we will finish it today. Okay, now let's continue. So I have here once more video regarding the circuits, hydraulic circuits.
The oil tank in a hydraulic system has several functions. First of all, it holds the oil supply for the system and receives the unpressurized oil flowing back from the system, which it then cools. But also, suspended matter, water, and air must be removed from the oil. In order for the oil to remain in the tank long enough for this to be achieved, the tank must have a large enough capacity.
Okay, this was regarding the tank, oil reservoir. Okay, let's come to the PowerPoint presentation. So we learned the how can adjust the speed, flow rate, that means flow rate, and the pressure, forces, and so on. So now let's continue with the hydraulic motors. Huh? So hydraulic motors, those are hydraulic rotary actuators. So hydraulic motors convert the hydraulic energy into the mechanical energy. So they are derived components and generate rotary motion or movement. So in machine, we explained at the beginning, in machines we have linear motion, rotary motion, and semi-rotary motion. So in all of them, we need to proceed the work, to do the work. So therefore, based on the need or application, we have to select linear actuator or rotary actuator or semi-rotary actuator, and then we have to consider, of course, by selecting of the linear rotary actuators, the forces, speeds, and all these facilities or properties we need for the work, for the application. So this is the hydraulic motor. Here you see this is the hydraulic motor, and this is the motor as a full rotating. This is oscillator, or let's say the semi-rotary actuator. This is a linear actuator. All of them we need in the machine. And here we have the pump. And the prime power, that means the electric motor, and the electric motor connected to the pump and drive the pump, and pump produce the hydraulic energy or convert the mechanical energy into the hydraulic energy. And we have here the valve, and valve drive the actuators. Already we learned. What is a hydraulic motor? It's a device which converts the hydraulic energy, that means power generated by the pump, into mechanical energy power, and the mechanical energy or power in the form of torque and rotation. That means RPM. So for a hydraulic pump, the main function is to displace as much oil as possible per revolution. So to achieve this, an optimum volumetric efficiency at the cost of mechanical efficiency is required. On the other hand, the hydraulic motor has the deliver maximum mechanical power at the load point. So hydraulic motors also can be divided in at the beginning in three sections. The one of them is the general geared motors and vane motor and the piston motor, like pump we discussed. And gear motors can be divided into external gear motor, internal gear motor, and annular gear motor, and those are the constant motor. That means the volume cannot be changed. They need we cannot change the speed regarding the volume. I mean, we cannot change the volume. So that's the correct explanation. So the hydraulic motor, the vane motor, and internally pressurized or externally pressurized. So those are constant and adjustable motors. So we can adjust the flow rate. And here we have the piston motor and radial piston motor and axial piston motor, as we discussed also in the section of pump. So hydraulic external gear motor, we have seen how does it work. External gear motor, maybe once more I can show you here.
Addition, the control blocks the pressure line, which prevents from rising any further. For example, because of its direction.
It's also not. Where is it?
The power control section. The hydraulics.
Where is it mentioned? Here, okay.
This hydraulic pump is an external gear pump. This is how fluid flow is created. The suction chamber is connected to the oil tank. When the two gear wheels turn, the volume of the chamber increases slightly whenever a tooth leaves a gap. This creates a partial vacuum in the suction chamber, which then causes the oil to be drawn out of the tank.
So the geared hydraulic motor function is also the same. Here we drive one of these gears with electric motor, and in case of pump, in case of hydraulic motor, we apply the pressurized oil from here, and it turns, rotates. So this is the main difference actually, but the function-wise same.
Oil is transported between the gear teeth along the chamber walls to the pressure chamber. The intermeshing teeth prevent the oil in the middle from flowing back. The oil now flows from the pressure chamber into the line, where it's displaced by the oil being supplied continuously from the gear wheels.
Okay. So this is the gear pump, hydraulic gear pump. It works like this. We apply the pressure, the pressurized oil from here. This is the inlet and this is the outlet. And the red one is the pressurized oil. And you see, and this pressurized air, pressurize the oil, apply the pressure to the surface of the gears here from that side, and it starts to turn. And also here, turn in that direction. So then we create, by pressurized hydraulic oil, we create here the rotation. And the oil, after the passing the pressure zone, so the oil can flow free into the tank or reservoir. And this is the symbol of hydraulic motor. And cross section of the direct drive gear rotor motor here. This is another hydraulic motor. You see the different profile. It's not gear, but different profile, which are work in connections. So internal gear motor says it here, two categories: direct drive gear rotor, or here it works much like a rotary engine, and two gears in inner and outer, and the pressure pushes them around the center point, turning a shaft. So the shaft is turning, then torque is generally by differential pressure across these tools. So another type of pump, motor, hydraulic motor, is cross section of a balanced vane motor, rotating group. This is a vane motor. You see, we apply the pressurized oil or fluidic from here, and it turns in that direction. So into entrance, we apply the pressurized oil, and those are the inlet here, and those are the outlet. Outlet, I mean after giving its pressure to the rotation. So spring-loaded vanes, those are the spring-loaded. The vanes are spring-loaded. Let's use here the laser pointer, spring-loaded here vanes. So are connected to a rotor here, as connected to a rotor here. This is the rotor, the turning part. So the rotor turns inside a cam, a ring, elliptical hole. This is a cam elliptical hole here, the elliptic. So, and that's the reason why here the vanes are moving up and down, and by moving up and down, taking oil in and pushing out. So the vanes slide in and out of the slots in the rotor to make contact with the cam well, as you see here. So the vane, you see here, the vanes is here in the minimum and here the maximum, and so on. So where we have eccentricity, this is the small eccentricity, come to the minimum, and the maximum eccentricity comes to the maximum. Another rotary actuator, hydraulic rotary actuator or hydraulic motor, is the fixed displacement inline piston motor. This is a piston. You see here the piston, so it is turning like this. And as here the shaft is turning. If the pistons moves up and down like an internal combustion engine, it creates a rotary motion. That means the linear motion in that direction is the pressurized inlet, so pressurized oil inlet. So the linear motion in that direction converts these inline into the rotary motion. Maybe it is seeable, so I can show you the okay, here. Rotary, hydraulic, hydraulic, rotary actuator. Or let's see, hydraulic. So here maybe we can see that. Okay.
This is a fixed displacement axial piston motor. The major components of this motor are the housing, port plate, valve plate, swash plate, cylinder barrel, pistons, piston shoes, shoe plate bias spring, and the output shaft. The cylinder barrel is fixed to the output shaft. The pistons reciprocate in and out of the cylinder barrel on an axis parallel to the output shaft. A bias spring and the shoe plate hold the piston shoes against the swash plate and the barrel against the valve plate. The swash plate sits at an angle to the pistons. As pressurized fluid enters the inlet, it is fed through a kidney-shaped opening in the valve plate to the 3 or 4 pistons situated over the opening. Pressure against the end of these pistons creates force which acts at an angle to the swash plate. These pistons are pushed outward in the barrel towards the swash plate. As this happens, the piston shoes slide across the surface of the swash plate. The result is an output torque, which causes the output shaft, the pistons, and the barrel to rotate. The pistons over the outlet area are being forced into the barrel towards the valve plate. Return oil from the 3 pistons is forced through the other kidney-shaped opening of the valve plate and out the outlet port. When the flow to the motor is reversed, the inlet becomes the outlet and the outlet becomes the inlet. The motor now rotates in the opposite direction. Output speed of the fixed displacement axial motor is proportional to the input flow. Drive torque is proportional to the difference in pressure between the motor inlet and the outlet. Any internal leakage passes into the area between the rotating group and the housing. This leakage is directed from the case drain port directly back to the reservoir.
Okay, so maybe vane motor. You see now the hydraulic axial motor here. This is radial motor, hydraulic motor, not axial. This is radial. So you see, it's moves in radial direction, but it creates also rotary action, rotary motion. Okay. We have also seen the radial piston motor. Radial hydraulic piston motor. This is
an axial piston pump is a pump that has a number of pistons in a circular array within a cylinder block. There are 2 designs are most relevant, the swash plate configuration and the bent axis configuration. In both cases, the angle the swash plate or the bent axis mechanism determines the effective stroke of the piston. Bent axis pumps design. In a bent axis piston pump, the cylinder block turns with the shaft but at an offset angle. The piston rods are attached to the drive shaft flange by ball joints. Most bent axis piston pumps consist of a few basic components: port plate, spherical siding surface, drive flange, drive shaft, shaft seal, flange, retaining rings, housing, bearing, piston, axis, cylinder block. The bent axis mechanism is a pumping machine, the displacement pistons of which are arranged at an angle to the drive shaft axis.
As
As the
interesting to
drive
see
shaft rotates, the cylinder block is caused to rotate by the pistons.
how the linear
The
motion
pistons move up and
converted
down
into the
within the
rotary
cylinder
motion.
block bores. The length of stroke is dependent on the angle of the bent axis. Fluid is fed to the low pressure, then, as the pistons moves, delivered into the high pressure port. Swash plate piston pump design. Most swash plate piston pumps consist of a few basic components. Flange, shaft seal, bearing, swash plate, drive shaft, piston, cylinder block, housing, port plate. The swash plate mechanism is a displacement mechanism, the displacement pistons of which are arranged axial to the drive shaft. The reaction force of the pistons is carried by the swash plate. As the drive shaft rotates, the cylinder block is driven by means of spline. The pistons move up and down within the cylinder block bores. This movement is dependent on the angle to the swash plate. Fluid is
Okay.
fed to the pump via the low.
Okay, that's enough. The vane pump, vane motor, hydraulic vane motor. Maybe I can show you the vane motor. Gear motor we have already seen. So as this vane motor, where is it? Here maybe. So this is okay. Vane motor,
In a previous lesson, we saw that pumps convert the mechanical energy of a turning shaft into hydraulic energy in the form of pressure and flow. This pressure and flow can be converted into linear mechanical force by cylinders which apply force in a straight line to extend or retract a cylinder rod. In this lesson, we will see how pressure and flow are converted into rotary mechanical force by hydraulic motors. We will also see how the efficiency of motors can be changed, so the force they develop can match the work being done as closely as possible. Three types of motors are commonly used in industrial hydraulic systems: the vane motor, the gear motor, and the piston motor. While each of these motors looks similar to its counterpart pump, each operates on a principle exactly opposite of the pump. That is, hydraulic motors take fluid under pressure, apply it to the surface area of an internal moving part to create a rotary force, and then return the fluid to tank. When operating any motor, two main factors must be considered: torque and speed. Torque is the rotary force applied to the shaft, usually expressed in pound-inches. Speed is the rate at which the shaft turns, usually expressed in revolutions per minute. Let's look at a vane motor to see how pressure and flow in a hydraulic system affect the motor's torque and speed. Like the vane pump, the vane motor has a rotating group with vanes that ride along an offset cam ring. Fluid moves in and out of the motor through port plates. As system pressure rises, the force applied to the vane increases, and the rotary force developed at the shaft, the torque, also increases. As long as the size of the motor remains the same, increasing the pressure will increase the torque. If pressure drops, torque drops. A similar relationship exists between flow rate and speed. If flow through the motor increases, then the vanes will turn faster, and the speed of the shaft will increase. Again, this direct relationship between flow rate and speed is the same for all hydraulic motors. Increasing the flow rate will increase the speed, and decreasing the flow will decrease the speed, as long as the size of the motor remains the same. The size of a motor means its displacement, or how much fluid it can hold. In a vane-type motor, changing the displacement can only be done by changing the cartridge assembly, which is the rotating group and the cam ring sandwiched between the port plates. Increasing the size of the cartridge assembly without changing the pressure will increase the torque, because the vanes of the larger cartridge assembly have more area exposed to pressure. Decreasing the size of the cartridge assembly without changing the pressure will decrease the torque, because the vanes in the smaller assembly will have less area exposed to pressure. Increasing the displacement without changing the flow rate will slow the motor down, because the same amount of fluid has to fill a larger space inside the motor. And decreasing the displacement without changing the flow rate will speed the motor up, because the same amount of fluid only has to fill a smaller space inside the motor. Now, let's take a close look at how each type of motor works. In a vane motor, the motor won't turn until there is a seal between the vane and the cam ring. That means that centrifugal force cannot be used to force the vanes out to the cam ring at startup. In some vane motors, springs are used to hold the vane against the cam ring. This can be done with a coil spring or with a spring attached to a post. In either case, once the motor is turning, fluid pressure is directed to the underside of the vane to help maintain a tight seal. Fluid pressure may also be used to force the vane out before the motor starts. This is done by using a check valve, which prevents fluid from entering the motor inlet until pressure is high enough to force the vane out against the cam ring. Gear-type hydraulic motors operate in a way that is similar to vane-type motors, except pressure at the motor inlet pushes against the sides of the gear teeth, forcing them to rotate. A tight seal between the gears and the housing minimizes fluid leakage past the teeth. The torque created at the motor shaft depends on the pressure at the motor inlet and on the exposed tooth area. The greater the pressure, the greater the torque, and the more exposed tooth area, the greater the torque. The movement of the gears in the gerotor motor is similar to the gerotor pump. Pressurized fluid enters the port plate, pushing on one side of one tooth of both the inner and the outer gear. Since fluid on the outlet side is allowed to exit through the outlet port, there is very little pressure to oppose the gear movement, and both gears rotate. The torque developed is based on how much pressure there is at the inlet port and on the size of the gears. The higher the fluid pressure, the greater the torque at the motor shaft, and the larger the teeth, the greater the displacement and the greater the torque. In a piston motor, fluid pressure pushes against the pistons. The piston shoes are forced to slide up and around the swash plate, turning the cylinder barrel as they move. After each piston passes the top of the swash plate, it starts back down, forcing fluid out of the piston bore and through the outlet port as the shoe and piston ride back down the swash plate. Increasing the pressure forces the piston shoes more firmly against the swash plate, increasing the torque applied to the cylinder barrel and to the shaft. Unlike vane motors and gear motors, piston motors can be reversed without changing the direction of flow through the motor. This type of motor is called an over-center piston motor, because all that's needed to reverse the direction of rotation of the shaft is to tilt the swash plate past or over its center. As the swash plate is tilted toward vertical, the motor displaces less and less fluid. Usually, to reverse direction, the motor is stopped. When the motor is restarted with the swash plate tilted over center, the piston shoes, which had been rotating in one direction, go back the other way, turning the cylinder barrel in the opposite direction and reversing the direction of the motor shaft.
So it's enough now, huh? So let's come to the slides. So the hydraulic motors already discussed, the fixed displacement inline piston motor and the radial motor. We have also seen radial piston motor. We have also seen with video. And variable displacement band axial piston motor, we have also discussed. So here we can variable, that means we can, the flow rate can be varied, and therefore the speed also can be varied. So in one example of variable displacement motor, the angle is altered to change the displacement. That means this the angle of this plate here. So, and therefore this is, you see this arrow is adjustable. It means adjustable in one direction. And here a limited rotation actuators, that means semi-rotary actuators, moves from this and from, let's say this is the moving part, the vane can move in that direction or in that direction. Also sometimes called oscillator, has limited movement, high torque, and so on. So performance regarding the hydraulic actuators, the efficiency, how can we measure or calculate the performance? The efficiency is very important. And there is two factors, internal leakage and internal friction. So volumetric efficiency and speed decrease due to the leakage. So leakage is not, let's say, the desired. So mechanical and the internal friction, mechanical efficiency loss due to torque loss. And those are the parameter here given how you can evaluate. And here also regarding performance, this is vane motor. You see here, this is the vane here moving up and down here, and based on the placing in the eccentric hole, displacement is measured in cubic inches per revolution, or but the inch is not, I mean, we don't use, but I mean, this is the some companies are using still. So there are some formula. How can you calculate the speed and flow and the pressure and torque and so on? Okay. So do you have any questions regarding the hydraulic actuators or hydraulic power, on using of hydraulic power? Circuit fundamentals. Is it like the hydraulic motor? Not here. No. I've seen one hydraulic motor in my videos. I don't know where is it here. Maybe somewhere. No, also not. Pressure relief. Here could be. Also not. Also not. Okay. Okay, here we have hydraulic. This is hydraulic
motor. In this
motor
circuit,
here.
the motor is not to start running until a certain pressure on the cylinder has been reached, for example, for clamping. A pressure relief valve makes sure that the pressure line to the motor doesn't open until the required pressure on the cylinder has been reached. So the valve serves here as a sequence or pressure sequence valve.
So you see here the hydraulic motor. It provides the rotary motion here, but used in with a linear actuator together, and the pressure relief valve used in a different function here. That means we use the linear actuator. So with this linear actuator, let's say we clamp something, and at the end of the clamping, if the system arrived the desired pressure, so then pressure relief valve open the pressurized oil fluidic into the motor, and motor can start to turn. That means you can cut a screw and so on. And I can show you also in a fluid sim. For example, if let's say we have a linear actuator, so I have to take out all of them. So I'm going to simplify the circuit. So here I have used the hydraulic motor somewhere. We have hydraulic motor. Where is it? No. Here. This is the pump. And it's hydraulic motor. So let's say the hydraulic motor here. Huh? So then, and the pressure relief valve. Let's copy one here. Copy. And put here. So, okay. So then, okay. Here. After piston arrive its final position, okay. Piston arrive its final position. Okay, this is connected to the tank here. Okay, so, and then, okay, then this has to be connected here. Good. Okay. That means now we drive the cylinder. So, and here, let's, okay, this is 15. After arrive the piston its advanced position, then motor will start to turn. You see now. So then motor start to turn. Huh? So not before piston arrive its final position. So please pay attention. After piston arrive its final position, the end position, then hydraulic motor start to turn. Not before, because the reason is after piston arrives its final position, the pressure is increasing. So pressure is increasing. So then after after pressure increased, so the level of the pressure arrived the level which we have adjusted here, 15 bar, and then it's open. This valve is open, and then oil can flow via this valve into the motor, and motor start to rotate like this. Huh? So I can reduce a little bit. So that's 10. Let's have 10 here. And okay. Then let's see. So you see, it is turning. The rotor is turning. This is the RPM is 254. The RPM of the motor. but the motor starts to turn after piston arrives its final position, like this. So, okay. We use in the same circuit linear actuator and the rotary actuator, and in connection. That means, let's say we have a here workpiece, and workpiece has to be clamped by this linear actuator, and then motor has to start it after clamping is finished, start it to cut a screw or to cut something, or to do any initial work based on the rotary motion. So then we organize or arrange the sequence actually. First the linear motion, and then the rotary motion, like this. So first linear and the rotary motion. Okay. So if you don't have any question regarding the hydraulic actuators, linear actuator, rotary actuator, semi-rotary actuators, hydraulic power, and so on, and the pressure regulating or flow rate regulating, and so on, then I will finish this part, rotary actuators, say hydraulic actuators. So next lessons, I will arrange the homeworks, and then start to talk about the electromechanic actuators. That means electric motors or electromechanic actuators, let's say. Okay. So then make a break, 15 minutes. After 15 past 4, we will meet again.
Hojam, I think my name is not on the list.
So we will see whether your name is on the list or not. Wait, please.
And also, I can't hear anything.
Sorry?
I think I'm facing a technical problem.
So we will see now first. I'm creating the list. Okay. So then let's come.
Sorry, Hojam.
Okay.
Sorry, Hojam, this is my first class. Did we have a quiz?
No.
What about a homework?
Homework I will give in. I'm going to give now today.
Okay. And this is a list for our lecture
Yes.
because I can't see my name here.
So are you coming from the mechanical engineering or mechatronics?
Mechanical.
Mechanical engineering. So let's
Yes.
wait. This is not mechanical engineering. This is
Okay.
mechatronic.
Okay.
This is
Sorry.
this is mechanical engineering. Okay, this is mechanical engineering. Huh? So then,
Yes, my name is there. I just see it.
okay. I have to dimmer. Okay, so. Okay, we have here 25 and here 32, so 57. 57, 57. 57, let's count those. So 57. Evet, so this is P actuator, H actuator, the mechanic actuator, sensor, network, hardware and software. 5, 4, 5, 6, 7. Okay. 7 grup. 7 çarpı 7, 56. 7 çarpı 8, 56. Bir kişi 8 grup olacak. Diğerleri 7. 8, 9. Okay. So, okay. Mechatronic machine. So then we can start. So, you can hear me?
Yes, hocam.
So I'm talking about the homework. So we will describe the homework. So do we have any list? I mean the grouped, shaped. So do you have a ready list now for the time being? Okay. So
What
the
list, hocam?
5 group is shaped already, okay? Not all of them. Only 5 groups, you mean? So let's see that. Okay. So here, what is this? Okay. You mean this one, huh? Okay. So I cannot work with this list because I cannot copy that. I cannot see. Or we can do following. You have the list. We can go through the list and we can shape it, huh? So like this.
Hojam, I think on this list also my name is not there on the email, on the 5 groups.
So it could be. I mean, you should talk to the Adel, huh? Adel is prepared the list. Maybe 1, 2, 3, 4, 5 groups. 1, 2, 3, 4, 5, 6, 7, 8.
Yeah, I
1,
didn't know that I should send it to Adil because this is my first class.
You did not send. Okay. So
Yes.
Adel, can you hear me? Adel, can you hear me?
Hello, Professor.
Can you hear me, Adel? Okay. So
Yes,
you
yes,
have
I
the
can.
list.
Yeah, I have.
You have the list in front of you.
Yes. Yes.
Okay. So then, because I cannot use the list, that I mean picture you made with camera and send. I just
Yes.
so then I cannot use it. So you read the name and I mark it. Okay.
All right.
So which one we start first?
The first group, first student is Nasser Al-Atasi.
Mechatronic engineering or the mechanical engineering?
Mechatronic, I think. They're all
Okay,
together, Hojam.
Huh?
They're all written together.
Okay, good. Then, so the first group, please read the name.
Nasser Al-Atasi.
Or the number is better. I mean, I can find much more easier.
Okay.
This one.
I cannot see your screen, Hojam.
Can you see the screen?
No.
My screen. You don't see that, huh? Okay.
No, I don't.
Let's share the screen. Okay. Can you see now?
No, we can't.
Okay. Let's try once more. Okay. Share the screen.
We can't see, Hojam. We can't see everything.
Adel, why don't you see that?
It's not showing for me, Hojam. I'm gonna leave and join in again. 1 second.
Please, you have to join, okay?
1 second.
Okay.
Okay, Hojam, I can see now.
Okay, the first one is you said Nasser Al-Atasi. Can you give the number, please? The ID number is much more better than I can follow. Adel, can you hear me? Adel?
I think there is a problem with his connection.
So somehow we have to finish that. If not, I will mark from the beginning, and I say 1, 2, 3, 4, 5, 6, 7, 8. 8. This 8 is one group. Okay. Then the next 8 is second group, and so on.
Hojam, we can go through the names one by one. I can see the screen now.
Through the name, okay?
Yeah, yes.
Okay. Give the name.
First one is Nasir. It's number 28. Yes, this one.
Nasir, okay. Let's have a color for that. Okay, Nasir, the second one.
Mohammed Harb. Is not on the screen right now. Oh no, I mean 29. Number 29.
29 here.
Yes, this one.
Okay. Let's have another color. This is two. Okay, so okay. Then
Mariam Al-Utari, number 23.
23. Mariam, okay. 23 Mariam, okay. Okay.
Number 20. Abdul Bari Abdul Basit.
Okay.
Number 18. Muayyad.
18. Okay.
Nada Hussam, number 26.
26.
Yes.
Okay.
Last one is Hamza Mustafa Al-Askar. He's not on the list over here. He's probably mechanical.
Hamza is not in the list here.
No, he's not over here now.
Yes, I am mechanical engineering.
Is it here? Some maybe, huh?
I'm looking for it.
In mechanical engineering.
Yes, over here. He's number 5.
Number 5. Yes.
Number 5 here.
Yes.
Okay, Hamza. So then let's say this one is the group A, huh? Group A.
Hojam, we skipped one of them. Anas Khalaf. He's mechatronic.
We marked. Okay, we marked. Don't worry. So is it mechanical or mechatronic?
Mechatronic, I think.
Mechatronic. Okay.
Number, yes, 24.
24 here.
Yes. Nasser,
Okay.
thank you for reminding me. I skipped his name by mistake.
Sorry?
No,
Not
I'm talking
24?
to the guy that reminded me. 20. Yes, he's number 24.
Okay. So this is one group, huh?
8 students. Yes.
Okay. This group A.
Mm-hmm.
Okay, let's come to the second group.
Mahmoud Al-Zuyud. His
Mechanical or mechatronic?
I think I don't know. He did not say. Mahmoud.
Mahmoud.
Oh, number 9.
Number 9 here.
Yes.
Number 9. Okay. Let's mark it with. Okay. Mahmoud.
Muhammad Abdul Wahid. I'm looking for him. Maybe he's mechanical. I don't know.
And mechanical Muhammad Abdul Wahid.
No.
Not?
No.
Muhammad Khalid. Oh, no, not. Oh, it's interesting. Here maybe. Muhammad Abdul Wahid, huh?
Yes. He's mechatronics. I just asked him. But he has a problem. Yes, he has a problem in the system. Apparently, his name is not on the list.
Not on the list.
Yes, not on the list in your computer.
But is he registered?
I have no idea.
Mohammed is not this one, huh?
No, it's not.
Not okay. So he's mechatronic. Then let's write the name.
Okay. Hojam, he's registered, but his courses were taken off the O-Learn system.
But it is in now. This is the new list. I'm just taking. I've take from the O-Learn, share from the OIS. I mean, this is from the. This is the actual list, huh?
Okay.
If it is not, I mean, Mohammed Harb is not Mohammed Harb, huh?
No, it's not him.
Not. Okay, Mohammed
Abdul Wahid. Abdul Wahid. Abdul.
Abdul Rahim.
No, Wahid. W, not Rahim. Wahid.
Abdul Wahid.
Yes.
W.
Yes.
Abdul Wahid is okay now.
Yes, correct.
Muhammad Abdul Wahid.
Yeah.
So do you know the numbers? ID number?
Yes, it's 2002.
2002.
07.
07.
340.
340.
Yes.
Okay, so then. Okay, mechatronics, huh?
Yes, mechatronics. Yes.
So mechatronics, okay, system. Let's indicate it. So this is the second one, okay.
Second student is number 31, Raed Hassouna.
31?
Yes.
This here?
Yes, this one. In the same group.
Okay. This is the third one, huh? In this group,
yes.
New group. Okay,
yes.
Then?
Muhammad Sadiq Al-Khawlani, number 16.
Number 16, okay. Okay.
Hamza Mahmoud. I'm looking for him.
Hamza is.
He's not on.
Maybe on the other list, huh?
Yes, maybe we can.
Hamza.
He's not on this list.
Not here. So I don't know if it is not registered. It is not. I mean, it is a problem, huh?
Yes.
Why is not registered?
It's the same issue as that previous student. He has a problem in the system.
So is it mechatronic or mechanical?
1 second.
Is he mechatronic or?
I'm asking. 1 second.
Okay.
He's mechatronics, Hoca.
Mechatronic. Okay, let's come here. Mechatronics. So let's write the name, huh? Hamza.
Okay. Mahmoud.
Mahmoud. Is it correct? So Mahmoud.
Yes, correct.
Hamza Mahmoud.
Yes.
The ID number?
2002
2002
07
07
327.
327. Okay. Mechatronic.
Yes, correct. Yes.
Okay. So then we have to also mark it. So the next one in this group,
Abdul Rahman Hamad. Maybe he's above. He can go up.
Abdul Rahman.
Yes.
Let's see, where is it? Is it that? Abdul Rahman Hassan?
No, it's not.
Where is it?
Hojam, what is the full name of number 17? Can you check?
17.
Yes. What is? I just want to see the full name of the guy.
Abdel Rahman Mahmoud Ramadan Mahmoud
Yeah. What? Yes. What is the last word?
Is this one?
I can't see the last name of his. What comes after Mahmoud?
Mahmoud Ramadan Mahmoud Hamad.
Yes, it's this guy, Abdul Rahman Hamad.
This one?
Yes.
Hamad. Okay. Then mark. Okay. So then the next one. We have here 1, 3, 4, 5, 6. Okay. We have okay.
Mazen Al Jabali. His number 21.
21. Okay.
And then Nizar Muhammad, his
Nizar here.
Yes, number 4.
Nizar Muhammad. Okay. Then this group is finished.
This group is finished. Yes.
Okay. Then right here the group here. This group here, the B. Do we have here? No. Okay, B. I will mark also on that side. This is the group B. Okay. Let's copy him. And also here. Okay. So, and then the next group.
Third group now. Yes. Alpar Turaman. His mechanical engineering.
Alpar Toraman. Altar Toraman.
Yes, no.
This one, huh?
Yes. Yes.
So then market has use. Okay.
Amin Al-Wash. His mechatronics engineering.
Mechatronics. Okay. Must be in this list.
No, this is mechanical.
This is mechanical. Okay. Okay. Here. What's the name?
Amin.
No, not here. Amin, maybe another name.
She's saying number 19. Yes, number 19.
This 19.
Yes.
This one.
Yes, Hoja.
Amin. Okay. Good.
Number 27.
27, okay. Okay.
Omer Belli. I think he's
He's here
I'm not
somewhere.
sure.
I know him here.
Oh, number 1.
Yes. Okay.
Mert Demir. I'm not sure if he's mechanical or mechatronics.
Mert Demir could be mechanical. Let's see. Mert Demir. Unit. Mert, is it? Mert Demir here.
Yes.
Okay.
Ahmed Burak. He's number 8.
Ahmet Burak. Okay.
Görkem Urash.
Görkem is somewhere here. Moment. Is it
Yes, number
mechanical?
25.
Görkem here. Okay. Görkem is here. Good. Okay.
Omar Shwikani. I think he's mechatronics.
Omar. Let's see. Omar. Omar. Here.
Yes.
Okay.
Now this group is over.
This group over. Okay. This C. Sorry. C group. Third group. Okay. Good.
Yes.
And then
now
next
fourth
one.
group. Abdul Rahman
Yes.
Hassan.
Abdul Rahman.
Number 15.
15 here. Okay.
Yes.
Number 15. So this is another color. Okay.
Ahmad Nail Muhammad Musallam. He could be down on the list.
Yeah.
Yes, number 27. I mean 22.
This one?
Yes.
22.
Yes. Now number 14. Mundir.
14. Okay.
Amr Khattab.
Amir.
He's not over here. Go to the top of the list. He might be over there.
Amir is not. So not seenable. Huh?
Number 20. Number 20. On mechanical.
20 here.
Yes.
Okay. Yes. Okay.
Saleh Ahmed is not on the mechanical list.
Mechanical.
No, I said I think he's not on the mechanical list. He's probably on the mechatronics. Oh, yeah, number 5.
Number?
25.
25. Saleh Ahmed. Is correct?
Yes.
Okay.
Yes, correct.
Okay, Saleh Ahmed. Okay. The next one.
Muhammad Ali Al-Makbuli.
So
he's not on this list.
Here.
Oh, yes, actually number 2. Yes.
Number 2, huh? Okay.
Muhammad Fai.
Muhammad Fai. Not here, huh? So let's see it.
Mhm.
Muhammad.
Oh, yes, number 19.
19.
Yes.
Okay.
Amir Muhammad Ghurbani.
Amir. It's here somewhere. Attila.
He's not on both lists.
This is not in this list, and
No, I don't. I couldn't find him.
is it mechanical, or do you know that?
He is.
This is Mechatronics.
No, he is mechanical, but he chose the cars manual, so it needs time.
So it is mechanical or mechatronic?
Mechanical.
Mechanical. So what is the name? Let's write the name.
Mohammed Fai.
Mohammed Said.
No, I thought.
Fai. F-A-Y-E.
Okay, never mind.
Y.
F-A. Hoja, not S. F. F-A-Y-E.
F.
Mm-hmm.
A.
Y.
E. E. Mohammed Fai. Is it correct?
Yes.
I think it is the same of number 19.
So S is 19. Yes, I think so. Mohammed Fai here. It's the same. There's something wrong.
1 second. I think we were talking about another name. We were talking about Amir Muhammad Ghurbani. Yes, this student.
Now, this student Amir Muhammad, öyle mi?
Yes, Amir Muhammad Ghurbani, not Fai.
Amir Muhammad
Ghurbani, G-H-O.
G-H-O.
R. B-A-N-I. Yes.
B-A-N-I. It's correct now, huh? But I think we have this in the list. Amir Muhammad Ghurbani. I know him. Ghurbani. Not registered. Have in the list. Muhammad Ghurbani. So seems not in the list, huh?
Yes.
But you are sure this is from the mechanical engineering?
The guy said, I'm not sure. I don't know him.
Okay. Let's see the other list.
Yeah, he's not on the list.
Not on the list. Okay, let's come here. Okay, do you know the ID number?
Oh yes, it's 2002.
1 second, please. So 200
2
2
04
04
329.
329.
Yes.
Okay.
Now this group is over.
This group is over. Is this, let's say this is the mechanical engineering. Okay, here, mechanical engineering. Let's shape it with color. So, okay. Then this is the group C. Okay, C.
No, it's actually group
Okay.
D.
Huh?
It's actually
A,
group
B, C,
D.
sorry, D, D, sorry, it must be D, okay, right, correct, D. Yo, A, B, C, D, A, B, C, right? This is C, okay, yes, D, huh?
Yes.
Okay, the group D, so let's start.
The final group.
Okay,
Ahmed Haidar.
Ahmet Haydar.
Yes.
Ahmet Haydar is not here, is in
Oh,
mechanical.
it's number 3.
Number?
No, it's mechatronics number 3.
Ahmet Haydar,
Yes.
here, okay, so Ahmet Haydar, let's have that, this color. Okay, Ahmet Haydar, okay.
Furkan Öğretici. He's mechatronics. Number 12.
Furkan, number 12, okay. Okay.
Number 6. Jamil Noor.
Cemile Nur. Okay.
Taibe Biter. I think 13.
Taibe. Here, okay. Correct. Okay, Taibe.
Buluthan Kaplan.
Bulutan is here somewhere.
Yes,
Okay.
30.
Okay, Bulutan Kaplan.
Abdelhak Hosu. He's not, I don't see him in the mechatronics.
Okay, Abdulhak, let's come here.
Number 1, number 13.
Number 13, Abdullah Hussein. Okay.
Is number 3.
Number 3. Fuat Bayrakçı. Okay.
And then number 9, Jawad.
Number 9. Jawad.
Yes.
Okay.
This group is over as well. We have 5 groups. Each group has 8 students in it. The rest of the students, I didn't get their names and numbers.
Okay, the rest is not grouped. Rest of the students.
Yes.
Huh? Okay.
Yes. The rest of the students, I don't have. I don't add them in a group.
Okay, Hojam.
Yes.
I just sent Adil my name and ID number. So
yeah,
can you put me?
There's. I got it, but you're alone, so it's gonna be random with the rest of the students.
So we have 1, 2, 4 group. We have 4 group. Already.
5, not 4.
No, 4. 1, 2, 3, 4 group we have, isn't it?
Hocam kahverengi olanı eklemeyi unuttunuz.
Kahverengi unuttuk, doğru. Dur. Buradan kes ve buraya koy. It's the last one. Buraya kahverengi koymam lazım. Aynen. O muydu o? Şuydu galiba, değil mi? Evet. Doğru. Buna da D diyelim. D dedik. Pardon. Buna D diyelim. Doğru. E olsun o zaman. E olacak. Okay. So 5 group. A, B, C, D, E. Is it now correct, huh?
Yes, it's correct.
So, okay. So that means 5 times 8 var, isn't it?
Yes.
40 students already covered. 40. We have now 17.
17 more. students, yes.
17 more students. That means 2 groups we need. Okay, 2 groups. So the rest I will shape, okay?
All right.
I will shape the rest. So then let's write here the first one. Pneumatic actuators, okay. Hydraulic. Actuators, okay. Electric, electromechanic actuators, okay. Actuators, and then sensors, okay. Network, and then the rest. Oh, sensors, and here networks, hardware, and software. Okay. So I will give also the content. I mean, what you have to do. Let's do it. Okay. Okay. We have here one guy, Atilla Çağatay. Ondan sonra here we have, okay, 1, 2, 3, 4, 1, 2, 3, 4, here. So can you hear me?
Yes, yes.
No, I can. I think we can stop now. So you all have now the groups have the homework I discussed now. So the rest will be. I mean, I can shape it here. So this is here we have 1, 2, 3, 4, 5 guys. So then let's do it. One in a color which could be here is okay. So and then okay, and then so this is the group. Then let's come to the next one. We have 5 there, 5, and 7 and 8. 8, okay. Then this is the group F. F. So, oh, we have more, huh? This is the hardware. So then I put this also in this group. 10. 10, okay. Okay, 10 kişi de bunlar olacak o zaman. Okay, then the next group is and then the next group. Not this one. Okay. Okay, this is finished now. Okay. So I think we can stop the lesson today, huh? We shaped the group at least and we distributed the homework. And next week in our lessons, I will tell you about the content, what we are going to do, regarding these topics. So have a nice week and bye-bye.